Thank you, Chairman. Good afternoon, everyone. Today, I will present our study on infrasound signals from fireworks, focusing on waveform deformation and attenuation during propagation. At the onset, I should note that while our initial aim was to identify nonlinear effects, we were not able to confirm them clearly. But we did observe distinctive phenomena when I would like to share with you. With recent advances in compact and highly accurate infrasound sensors, we are now able to capture various phenomena in much greater detail. Against this background, we conducted observations of infrasound generated by fireworks in order to better understand waveform deformation and attenuation during propagation. The fireworks we studied were part of weekend events at Moomin Valley Park, a theme park located near my home. Taking advantage of the regular launches during the holiday season, we deployed portable pressure sensors at sites ranging from very close to several kilometers away from the launch site. For our observations, we used portable pressure sensors, specifically a parascientific digital quartz resonator sensor, model 6016B. Each sensor sampled at 100 Hz with an IRR filter at a corner frequency of 22 Hz. Two identical sensors were employed. One was installed at my home as a fixed observation site, and the other was carried to different locations to study the propagation processes. This figure shows the distribution of the observation site. You can see the middle of this figure, artificial lake. Theme park locates around this artificial lake, and red reverse triangle indicates the launch site of the fireworks, and 4 yellow triangle, reverse triangle indicates shows the observation site, and the lowest one is my home, fixed observation site. And left side temporary observation site is a parking lot of the supermarket where I often buy groceries. And observations were conducted during the summers of 2024 and 2025. And this slide shows the actual observation settings. Left picture shows the situation of, at my home. At my home, I had a clear view of the fireworks, allowing continuous monitoring. And the right picture shows the observation at near the launch site. At the theme park, observations were made from within the audience, blending in with the spectators' area during the fireworks shows. The fireworks lasted 15 minutes, and in each session, we observed more than 100 signals at one or two sites. This figure shows an example of the entire time series observed near the launch site. Each tick corresponds to a firework explosions. Similar data were also recorded at my home. Each signal was then extracted, expanded, and compared across events. So let us now look at the waveform shape. Here, all signals are shown on the same vertical and horizontal scales. There are the waveforms observed at near the launch site. The horizontal distances from the launch site to the observation site was approximately 300 meters. And most fireworks exploded at altitude around 100 meters, with the highest reaching about 200 meters. Before the observation, we expected to see the typical N-shaped shock wave, a sudden positive pressure followed by a sharp negative phase. In practice, we did observe such N-shaped signal like left side figures, but also many waveforms with only a weak negative phase. Based on these features, we roughly classified the signals into two waveform types. We could not explain the reason why these different types of waveforms exist, obviously. But it might be possible that the variation between the two waveform types reflects differences in yield. Also, we cannot exclude other explanations such as the explosion mechanism or environmental effect. So please advise or comment from later why such different type of waveforms exist. That's one reason. Next, we examine the duration of the initial positive pressure phase. Signals with different amplitudes were extracted and compared. Interestingly, the duration of the initial positive phase appeared nearly constant regardless of amplitude. This may suggest that the expansion time of a small atmospheric explosion is essentially independent of yield. On the other hand, the amplitude varied over several orders of magnitude, so we believe it is unlikely that the 100 Hz sampling rate obscured the differences. In any case, these results indicate that estimating explosion yield from the duration of the initial positive phase may be difficult, at least for small explosion-like fireworks. And finally, let us compare entire waveforms, including the coda. Left figures have three waveforms. These are examples of signals from the same firework observed at my home on different days. You can see that they are remarkably similar, although minor differences arise due to factors such as wind along the propagation path. By contrast, signals from the same firework observed at different locations on the same day, right figure shows this contrast. these waveforms are clearly different. This highlights that the observed waveform is strongly influenced by the local environment of the observation slide. Therefore, when discussing waveform shape, propagation effects such as reflection and convolution should be carefully taken into account. Okay, I will summarize my presentation. We attempted to observe infrasound signals from fireworks in order to study waveform deformation and attenuation during propagation. Although nonlinear deformation was not clearly identified, several distinctive phenomena were observed. We believe that the insight obtained here may be useful for interpreting shock wave propagation in other contexts. In addition, fireworks observation appears to provide a suitable test case both for understanding shock wave characteristics and for practicing infrasound observation technique. Thank you for your attention.
Thank you, Nobuo-san. And now it's time for questions on maybe for suggestions, opinions. Yep.
Good afternoon.
Yeah.
Well, it's a very interesting research, and I just have a comment. I had been studying lightning for around 10 years. So in the last year, I saw a similitude, as you're talking about. Lightning happens in a very short time, around microseconds. Yeah. So I think maybe I am not a seismologist, but maybe the waves that you have are very similar to the waves that I found on a monitoring seismic station on a volcano. So maybe it could be that propagation that we have a relation about that for the fireworks. Thanks.
Thank you. Yeah, right-wing signal is a N-shaped shock waves I saw. So right side waveform shape, I didn't identify the right-wing signal. So why such kind of weak negative pressure phase at the fireworks? I cannot follow this characteristics or behavior. So please give me some advices or comment from your experts.
I have something, maybe, I don't know, my idea. Did you consider to use seismometers or Raspberry shake in the sites to combine observations?
Yeah,
like a coupling?
Yes, this is a digital resonator sensor and 100 Hertz sampling rate, and
it's
22 Hertz corner frequency is a high cut filter, anti-aliasing safe filter. And this first positive pressure phase duration time is 0.05 second, around 0.05 second. So 20 Hertz, around 20 Hertz.
Yeah.
So we observed the correctly, I think. So this is a real waveform, I think.
Yeah, okay. Maybe we can talk after, yes, about this because we... Sorry, Yele, please, sorry. So.
Thank you for a nice talk and observations. The waveforms that you show here on the right-hand side look like very common blast waves to me that could be modeled with a Kinney blast wave model. And depending on the propagation conditions and dispersion, the waveforms could very easily evolve into something that you see here in the middle. So perhaps taking into account possibly complex propagation conditions could explain your data set. But there is quite some literature on these blast wave models.
Oh, I see.
I could recommend.
So wind condition will reflect or influence this.
And indeed, I also agree with the previous person who asked the question. It is also quite common in lightning to see these waves.
Okay, thank you.
Yeah.
Okay, thank you. We move to the next presentation.
Yeah, feel free to give him feedback and comments after the session.